Topic: Transmission Media. S. Saravanan. Lecturer. Women's Polytechnic College. 1.3 Transmission Media. A transmission media is a physical, material, substance, solid, liquid or air, which can propagate energy waves. The transmission medium for sound received by the ears is usually air. Comes under OSI Layer 1 physical layer. Each transmission medium requires specialized network hardware. Transmission media are classified as one of the following. Guided, or wired, waves are guided along a solid medium such as a transmission line. Unguided, or wireless, transmission and reception are achieved by means of an antenna. Guided transmission media uses a cabling system that guides the data signals along a specific path. The data signals are bound by the cabling system. Guided media is also known as bound media. There are three basic types of guided media: twisted pair, coaxial cable, optical fiber. Unguided transmission media consists of a means for the data signals to travel but nothing to guide them along a specific path. The data signals are not bound to a cabling media and as such are often called unbound media. There are four basic types of unguided media: radio waves, infrared, LOS, line of sight, VSAT, very small aperture terminal, twisted pair. The wires in twisted pair cabling are twisted together in pairs. Each pair would consist of a wire used for the AND VE data signal and a wire used for the VE data signal. Any noise that appears on one wire of the pair would occur on the other wire. When the noise appears on both wires, it cancels or nulls itself out at the receiving end. The degree of reduction in noise interference is determined specifically by the number of turns per foot. Increasing the number of turns per foot reduces the noise interference. To further improve noise rejection, a foil or wire braid shield is woven around the twisted pairs. There are two types of twisted pair cable: shielded twisted pair, STP. Unshielded twisted pair, UTP. Shielded twisted pair, STP. Shield can be woven around individual pairs or around a multi-pair conductor, several pairs. Unshielded twisted pair, UTP. The characteristics of the unshielded twisted pair cables, UTP, are similar in many ways to STP, differing primarily in attenuation and ME. Several twisted pairs can be bundled together in a single cable. These pairs typically are color-coded to distinguish them. UTP cable is available in the following 5 grades, or categories. Categories 1 and 2, voice grade cables are suitable only for voice and for low data rates, below 4 Mbps. Category 3, generally suited for data rates up to 10 Mbps. Category 4, consists of 4 twisted pairs, is suitable for data rates up to 16 Mbps. Category 5, consists of 4 twisted pairs, is suitable for data rates up to 100 Mbps. Coaxial cable. Coaxial cable consists of 2 conductors. The inner conductor is held inside an insulator with the other conductor woven around it providing a shield. An insulating protective coating called a jacket covers the outer conductor. The outer shield protects the inner conductor from outside electrical signals. The distance between the outer conductor, shield, and inner conductor plus the type of material used for insulating the inner conductor determine the cable properties or impedance. Typical impedances for coaxial cables are 75 ohms for cable TV, 50 ohms for Ethernet Thinnet and Thicknet. The impedance characteristics of the cable allow higher data rates to be transferred than twisted pair cable. Optical fiber. Optical fiber consists of thin glass fibers that can carry information at frequencies in the visible light spectrum and beyond. The typical optical fiber consists of a very narrow strand of glass called the core. Around the core is a concentric layer of glass called the cladding. A typical core diameter is 62.5 microns, 1 micron equals 10 to 6 meters. Typically cladding has a diameter of 125 microns. Coating. The cladding is a protective coating consisting of plastic, it is called the jacket. Single mode has separate distinct refractive indexes for the cladding and core. The light ray passes through the core with relatively few reflections off the cladding. Single mode is used for a single source of light, one color, operation. It requires a laser and the core is very small, 9 microns. Multi-mode. Large core, the light rays tend to bounce around, reflecting off the cladding, inside the core. This causes some rays to take a longer or shorted path through the core. Advantages of optical fiber. Noise immunity, RFI and ME immune, RFI, radio frequency interference, ME electromagnetic interference. Security, cannot tap into cable. Large capacity due to BW, bandwidth. No corrosion. Longer distances than copper wire. Smaller and lighter than copper wire. Faster transmission rate.